Hello friends, welcome to my channel. Let's have a look at problem 122, best time to buy and sell stock 2. So in this video, we're going to share a solution based on greedy method. So we greedily buy and sell the stocks and then add the profit together. So let's look at the statement first. So we are given an integer array called pieces, where pieces I is the price of a given stock on the ith day. So on each day, we may decide to buy and or sell the stock. So we can only hold at most one share of the stock at any time. However, we can buy it, then immediately sell it on the same day. So find and return the maximum profit we can achieve. So here are three examples. So in example 1, so the output is 7. So the explanation provides a strategy. So in example 2, so the prices are increasing. So one strategy is that we buy at price 1, then we sell at price 5. So the profit is 4. So in example 3, so the prices are in decreasing order. So the output is 0, so no profit. The constraints on this problem are the following. First, the prices list has a length which can be up to 3 times 10 to the power 4, a decent large number. And secondly, the elements in the prices array is in between 0 and 10 to the power 4. It's not negative in particular. So with that said, so let's explain the idea here. So we are going to greedily buy and sell, and then this is our strategy for doing this problem. So we are going to consider the difference array. So the idea is actually very straightforward. So as the goal is to maximize the profit, so we do not care about the transaction details. So we just need to find the difference in sequence, then add them together, add the positive entries. That's it. So here is some digest. First, let's look at example 1. So if we consider the difference in sequence, so we have 1 minus 7, that is negative 6, 5 minus 1, that is 4, and 3 minus 5, negative 2, 6 minus 3, 3, 4 minus 6, negative 2. Then the maximum profit is 4 plus 3, that is 7. So let's further digest. So if we look at this piece, let's pretend this is the prices. So there are actually different strategies we can try. For example, we buy at price 1 and then sell at price 6. So in this case, the profit is 5. So as we can hold at most one stock, so that's the maximal profit if we do this kind of transaction. So actually, it's better to do two transactions. For example, we buy at price 1 and sell at price 5. So this is one transaction. Another transaction is that we buy at 3 and sell at 6. So together, what we have is 5 minus 1. So this is one profit. 6 minus 3, another. So add them together, we get 7. So that's the maximal profit for this list. So example 2 is explaining the cancellation phenomena and its role. So for example, if we have prices like 1, 3, 4, 7, then the maximum profit is 7 minus 1, that is 6. In other words, we buy at 1 and sell at 7. So this case actually corresponding to example 2. So this actually corresponds exactly to the summation of the difference sequence, right? So 3 minus 1 plus 4 minus 3 plus 7 minus 4. So that is 2 plus 1 plus 3, that is 6. In other words, summation of all the positive elements of the difference array. So this cancellation behavior is nothing but the below statement in the problem. So you can buy it, then immediately sell it on the same day, right? So it plays a role of transition when we computing the maximal profit. So once we understand the method and digest the logic, so writing the code is a straightforward thing. So let's write the code directly. For convenience, and for fixing idea, I'm going to write with a little bit redundancy. So first, let's check the length of the prices array, just for convenience. So we can do this always because the prices is not empty actually. So if n less than 2, so in this case, so no matter we do transaction or not, there's no profit. So we're going to return 0. And then if the length is greater than or equal to 2, we can do the difference in subsequence. So diff equals, so prices I minus prices I minus 1 for I in range 1 to n. So notice that we are computing from the second one, right? Second one minus the first one. So if you write here 0, it's a mistake. The reason is when I equals 0, prices I minus 1 is negative 1. Price is negative 1, the last element. So it changed the code intention. So with that said, then we can just need to return the sum of positive element in difference. So delt for delt in diff if delt greater than 0. So we didn't put a list here because sum can accept an iterator. So that's it for this problem. It forms a full solution. Let's do a special case check first. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic case. So with this test finished, I guess that's about it for this problem. So it also demonstrated a use of the differencing technique. So with that said, I guess let's stop here. Thank you very much.